Hello, and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, and a 40 gigabit public network, you've got everything you need to run a fast, reliable, and bulletproof data platform. If you need global distribution, they've got that covered too with worldwide data centers, including new ones in Toronto and Mumbai. And for your machine learning workloads, they just announced dedicated CPU instances. Go to dataengineeringpodcast.com/Linode, that's Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. And to grow your professional network and find opportunities with the startups that are changing the world, then Angel List is the place to go. Go to dataengineeringpodcast.com/Angel to sign up today. And you listen to this show to learn and stay up to date with what's happening in databases, streaming platforms, big data, and everything else you need to know about modern data management. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as O'Reilly Media, Dataversity, and the Open Data Science Conference, with upcoming events including the O'Reilly AI Conference, the Strata Data Conference, and the combined events of the Data Architecture Summit and Graph Forum. Go to dataengineeringpodcast.com/conferences to learn more and to take advantage of our partner discounts when you register. And go to the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, read the show notes, and get in touch. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers. Your host is Tobias Macy, and today I'm interviewing Zhamak Dehghani about building a distributed data mesh for a domain-oriented approach to data management. So Zhamak, can you start by introducing yourself?
Hi, Tobias. I am Zhamak Dehghani, and I am the technical director at ThoughtWorks, a consulting company. We do software development for many clients across different industries. I'm also part of our technology advisory board. That gives me the privilege and the vantage point to see all the projects and technology that we use globally across our clients and digest information from that and publish that as part of our technology radar twice a year.
And do you remember how you got involved in the area of data management?
Sure. So I guess I've done earlier in my career, I have built systems that part of what they had to do was, as part of the kind of network management systems many years back, collect, real-time data from diverse set of devices across, hundreds of nodes, and kind of manage that, digest that, act on it. It was part of some sort of a network management observability. However, post that experience, most of my focus had been on distributed architecture at scale and mostly on operational systems. So data was something that was hidden, inside operational services in a distributed system to support what those operational systems need to do. The last 2 years and the last few years, both being on the tech advisory board for ThoughtWorks and also working with clients on the west coast of US where I'm located, I had the opportunity of working with teams that were building data platforms. So I support different technical teams that we have on different clients, and sometimes I go really deep on one client, and sometimes I stay kind of across multiple projects. So I came from a slightly left field from distributed systems and operational systems to people who've been building, who were struggling building kind of the next generation data platform for a large retail, or people who have been involved working with teams who are building the next generation analytical platform for one of the tech giants here down in San Francisco, and struggling to scale that. So I started, I guess, working in the last couple of years, working with teams that were heavily involved in recovering from the past failures and of data warehousing, data platforms, and building kind of the next generation, and seeing the challenges and the experiences that they were going through. I'm sorry, I can't name many of these clients that I work with, but they often fall into the category of large organizations with fairly rich domains and rich data sets where the state of the data is relatively kind of unpredictable or has poor quality because the organizations have been around for a long time and they've been trying to kind of harness the data and use it for many years.
And so you recently ended up writing a post that details some of the challenges associated with data lakes and the monolithic nature of their architectural pattern, and proposing a new approach that you call a data mesh. So, can you start by providing what your definition is of a data lake, since there are a lot of disagreements about that in the industry, and discussing some of the problems and challenges that they pose as an architectural and organizational pattern?
Sure. So maybe I give a little bit of a historical perspective on the definition where it started and what we see today as a general patterns. So I think data lake started term what was coined by James Dixon in 2010, and what he envisaged at the time was an alternative to data warehousing approach. But what he suggested was data lake is a place for a single data source to provide its data in its raw format, so that other people, whoever the consumers are, can decide how they want to use it, how they want to model it. So there was no, the contrast was with data warehouse in a way that data warehouse was producing pristine bottled data that they were well modeled. They had very strong schemas and designed to address very specific, I guess, use cases and needs around business intelligence and reporting and so on. Data lake, based on James Dixon initial, I guess, definition, was a place that a single data source provide unbottled data, raw data, and that other people can use. Later on, he actually corrected and enhanced that definition, saying what he intended for data lake to be one place for raw data from a single data source and an aggregate of data sources into raw data into one place from multiple data sources, what he called water garden. But I think his thinking around raw data versus bottled data stirred people's imagination. And what data lake turned out to be is a place that aggregates raw data from all of the data sources, all corners of the organization into one place, and then on to allow mostly analytical usage and data scientists kind of diving in and find out what they need to find out. And then it has evolved even from then onwards. Like if you see, for example, different data lake solution providers, and you look at their websites, whether they're famous cloud providers like Azure, Google, so on, or other service providers, the current, I guess, reincarnation of a data lake is not only a place that raw data from all the sources in the organization would land, but also it's a single place that pipelines to cleanse and transform and provide different views and different access on that data also exist as part of the pipeline of that data lake. I use the data lake kind of metaphorically. I meant by data lake really the incarnation of the current data lake as a single centralized and kind of monolithic data platform to provide data for a variety of use cases, anything from kind of the business intelligence to analytical to machine learning based, accumulating data from all the domains and all the sources in the organization. So based on that definition, we can, I guess, jump into the second part of your questions about some of the underlying kind of characteristics that these sort of centralized data platforms share.
Yeah, so I'm interested in understanding some of the organizational and technical challenges that they pose, particularly in the current incarnation of how everybody understands a data lake as being essentially a dumping ground for raw data that you don't necessarily know what to do with it yet, or that you just want to be able to archive it essentially forever. And also some of the organizational and industry trends that have led us to this current situation.
Yeah, absolutely. I think so I wrote this, I can go into that in a minute, but I want to preface that by kind of the litmus test that this article has given me to validate whether the challenges that I had seen was widely applicable globally or not. So I'll go into the challenges for a minute, but I want to, I guess, give a little bit of information on what has happened since I've written this article. So the challenges that I've observed that we can share in a minute, technical and organizational challenges, I observed working, with a handful of clients, and also seeing secondhand from the projects that we're running globally. However, since I've written the article, there are tens of calls that I received from different people, different organizations, kind of sharing the challenges that they have and how much this had resonated with them. And it was a confirmation that it wasn't just a problem in a pocket that I was exposed to, and it's more widely spread. I think some of the underlying challenges are related. So one is the symptoms that we see, right? So the symptoms, the problems that we see, the symptoms are around mostly how do I bootstrap building a data lake? How do I? It's a big it's a big part of your infrastructure architecture. It's a central piece of your architecture, but yet it needs to facilitate collaboration across such a diverse set of stakeholders in your organization. People that are building your operational systems, that are collecting the source data, generating essentially the source data as the byproduct of what they're doing. And those stakeholders really have no incentive in providing that byproduct or that data for other people to consume, because there is no direct incentive or feedback cycle into where the sources are. So there is this central piece of architecture need to collaborate with a diverse set of people that represent the source data, and also a diverse set of teams and business units that represent the consumers of the data, and all the kind of possible use cases that you can imagine for a company to become data driven, essentially to make intelligent decisions based on the data. So the symptoms that we see are either people are stuck bootstrapping, building such a monolith and creating those points of integration and points of collaboration, or people that have succeeded to create some generation or some form of that data lake or data platform, they have failed to scale, either onboarding new data sources and deal with the proliferation of the data sources in organization, or they have failed to scale responding to the consumption models, to different access points in the consumption models for that data. So you end up with this kind of centralized, rather stale, incomplete data set that really doesn't solve a diverse set of use cases. It might solve narrow set of use cases. And the fourth, I think, kind of failure symptom that I see is that, okay, I've got a data platform in place, but have I changed my organization to actually work differently and use data for intelligent decision making, take augment our applications to become smarter and use that data. So I just put the fourth maybe failure mode aside, because there are a lot of cultural issues associated with that, and I want to focus on perhaps more architecture. I know you can't really separate architecture from organization because they kind of mirror each other, and focus on what are the root causes, what are the fundamental characteristics that any centralized data solution, whether it's a warehouse or lake or your next generation big cloud-based data platform, share that leads to those symptoms. And I think the first and foremost is this assumption that data needs to be in one place. And when you put things in one place, you create one team around managing it, organizing it, taking it in, digesting it, and serving it. And that fundamental centralized view and centralized implementation is by default a bottleneck for any sort of scale of operations. So that limits how much organizations can really scale operationally use and intake of the data once you have a centralized team and a centralized architecture in place. The other characteristic that I think is leading to those problems. So first and foremost, I think is centralization that conflates different capabilities. When you create one piece of central architecture, and especially in the big data space, I feel there are two separate concerns that get conflated as one thing and has to be owned by one team. And one is the infrastructure, the underlying data infrastructure that serves hosting or transforming or access to the big data. at scale. And the other concern is the domain. What are the domain data in the raw format or in aggregate or model format? What are these domains that we actually try to put together in one place? And those concepts, the domains and also the separation of infrastructure from the data itself, gets conflated in one place, and that becomes another point of contention and lack of scale. And that leads to other challenges around siloing people and siloing skill sets, that has their own impact, that leads to kind of unfulfilled promise of big data by siloing people based on technical skills. A group of data engineers or ML engineers, just because they know certain tool set around managing data from the domains where the data actually gets produced and the meaning of that data is known, and separating them from domains that are actually consuming that data and they're more intimately familiar with how they want to use the data, and separating them into a silo. That's another point of pressure for this system, which also leads to other, I guess, human impact, like the lack of satisfaction, the pressure that these teams are under. They don't really understand the domains, and they're yet subjected to providing support and consuming, ingesting this data, making sense of it, and how fragile that interface between the operational systems and the data lake or the big data platform is, because those operational systems and the life cycle of that data changes very differently, based on the needs of those operational domains, to the data that the team is consuming. And that becomes a fragile point that you're continuously playing catch up, and the data team is continuously playing catch up with the changes that are happening with the data, and the frustration of the consumers, because the data scientists or ML engineers or people, that the business analysts that want to use the data, they are fully dependent on the silo data platform engineers to provide the data that they need in the way that they need. So you have a set of frustrated kind of consumers on the other side, and poor data engineers in the middle, trying to kind of work under this pressure. So I think there's a human aspect to that as well.
Yeah, it's definitely interesting seeing the parallels between the monolithic approach of the data lake and some of the software architectural patterns that have been evolving, of people trying to move away from the big ball of mud because of the fact that it's harder to integrate and maintain. And you have the similar paradigm in the data lake, where it's hard to integrate all the different data sources in the one system, but also between other systems that might want to use it downstream of the data lake, because it's hard to be able to separate out the different models or version the data sets separately or treat them separate because they're all located in this one area.
I agree. I think the reason, and I have a hypothesis as why this is happening, why we are not taking learnings from the monolithic, operational systems and their lack of skill, and the human impact of that, and not bringing those learnings to the data space. I definitely see, as you mentioned, parallels between the two, and that's where I came from. I came kind of a bit of left field to this, and to be honest, when I wrote this article, when I started first talking about it, I had no idea that I'm gonna, offend a large community, and I'm going to get sharp objects thrown at me, or is this going to resonate? And luckily it's been on the latter side, and a positive feedback. So I think definitely there are parallels between the two. My hypothesis is why data engineering or data platform has been stuck at least 6 or 7 years behind what we've learned in distributed systems architecture and more complex system design, is that the evolutionary thinking and the evolutionary approach to improving data platform is still coming from the same community and the same frame of thinking that the data warehouse is built upon. Even though we have made improvements, right? We have changed ETLs, like extract transform load, to extract load transform, ELTs, essentially with data lake. But we are still fundamentally using the same construct. If you zoom into what the data warehouses stages were in that generation data platform, and you look into, even Hadoop based or whatever the lake based models of today, they still have similar fundamental constructs such as pipelines, ingestion, cleansing, transformation, serving as major first level architectural components of the big data platform. We have seen layered, functionally divided architectural components back in the day when we tried to, 10 years ago, decouple monoliths. The very first approach that enterprises took back in the operational systems when they were thinking about how the heck I'm going to break down this monolith to some sort of architectural quantum that I can independently somehow evolve was, well, I'm going to layer this thing. I'm going to put a UI on top and a business, kind of process in the middle and data in the middle. And I'm going to bring all my DBAs together to own this and manage this centralized database that is, centrally managing data from different domains. And I'm going to organizationally structure, my organization in layers. And that really didn't work because the change doesn't happen in one layer. How often do you replace your database? The change happens orthogonally to these layers across them, right? When you build a feature, you probably need to change your UI and your business model and your data at the same time. And that led to this thinking that, you know what? In a modern digital world, the business is moving fast and the change is localized to those business operations. So let's bring this kind of domain-driven thinking and build these microservices around the domain where the change is localized so we can independently make that change. I feel like we are kind of following the same footsteps. So we've come from the data warehouse and a big data place and one team to rule them all. And then we're scratching our head to say, okay, how am I going to turn this into its architectural pieces so I can somehow scale it? And well, invert, flip the layered model 90 degrees and tilt your head. And what you see is a data pipeline. I'm going to create a bunch of services to ingest and a bunch of services to transform and a bunch of services to serve and have these data marts and so on. But how does that scale? That doesn't really scale because you still have those point of handshake and point of friction between these layers to actually meaningfully create new data sets, create new access points, create new features in your data, or introduce new data products in a way. And I think that's hopefully we can create some cross-pollination across the thinking that happened in the operations domain, bring into the data. And that's what I'm hoping to do with the data mesh, to bring those paradigms and create this new model, which happens at the intersection of those disciplines we applied in operational domains to the world of data so we can scale it out.
And another thing that's worth pointing out from what you were saying earlier is the fact that this centralized data lake architecture is also oriented around a centralized team of data engineers and data professionals. And part of that is because of the fact that within the past few years, it's been difficult to find people who have the requisite skill set, partly because we've been introducing a lot of new different tool chains and terminologies, but also because we're trying to rebrand the role definitions. And so we're not necessarily as eager to hire people who do have some of the skill sets, but maybe have gone under a different position title, whether it's a DBA or maybe systems administrators, and trying to convert them into this new role types. And so I think that that's another part too of what you're advocating for with this data mesh and the realignment of how the team is organized in more of a distributed and domain-oriented fashion, and being embedded with the people who are the initial progenitors of the data and the business knowledge that's necessary for being able to structure it in a way to make it useful to the organization as a whole. So I guess if you can talk through what your ideas are in terms of how you would organizationally structure the data mesh approach, both in terms of the skill sets and the team members, and also from a technical perspective, and how that contributes to a better approach for evolutionary design of the data systems themselves and the data architecture.
Sure. I think the point that you made around skill sets and not having really created career paths for either software generalists to have the knowledge of all the tooling required to perform operations on data and providing data as a first class asset, or really siloing people into a particular role, like data engineers who have chosen that path, perhaps from maybe a DBA or data warehousing path, and not having had the opportunity to really perform as a software engineer and really put the hat of a software engineer in place. And that has resulted into in a to a silo of skill set, but also lack of maturity. So I see a lot of data engineers that are wonderful engineers. They know their tools that they're using, but they haven't really adopted best practices of software engineering in terms of versioning, continuous delivery, like versioning of the data, continuous delivery of the data. These concepts are not well established or well understood because they're basically evolved in the operational domain, not in the data domain. And many wonderful software engineers that haven't had the opportunity to learn Spark and Kafka and stream processing and so on, so that they can add that to their tool belt. And I think for future generation of software engineers, hopefully not so far in the next few years, any generalist kind of full stack software engineer will have the toolkits that they need to know and have expertise in to manipulate data in their tool belt. I'm really hopeful for that. There is an interesting statistic from LinkedIn, and if I remember it correctly, from 2016, and I doubt that has changed much since then, that they had 65,000 people that had declared themselves as data engineers on their site. And there were 60,000 jobs available looking for data engineers only in the Bay Area. So that shows the discrepancy between what the industry needs and what we are enabling our people, our engineers to fulfill those roles. Going back to my little rant about career paths and developing data engineers. So I personally, with my teams, welcome the data enthusiasts that they want to become data engineers and provide career paths and opportunities for them to evolve in that role. And I hope other companies would do the same. So going back to a question around kind of what's a data mesh? What are those fundamental organizational constructs and technical constructs that we need to put in place? I'm going to talk about the fundamental principles, and then hopefully I can bring it together in one cohesive sentence to describe it. The first fundamental principle behind data mesh is that data is owned and organized through the domains. For example, if you are in, let's say, in a health insurance domain, the claims and all the operational systems, and you probably have many of them, that generate raw data about the claims that the members have put through, that raw data should become the first class concern in your architecture. So the domain data, the data constructed or generated around a domain concept such as claims, such as members, such as clinical visits. These are the these are the first class concerns in your structure and in your architecture, which I call them domain data products in a way. The second, and that comes from domain-driven kind of distributed architecture. So what does that mean? That means that at the point of origin, systems that are generating the data, they're representing the facts of business as we are operating the business, such as events around claims, or perhaps even historical snapshots of the claims or some current state of this claims. As they're providing those teams, the teams that are most intimately familiar with that data are responsible to providing that data in a self-serve, consumable way to the rest of the organization. So the ownership, the one of the constructs or principles is that the ownership of data is now distributed and is given to people who best suited to know and own that data. So that ownership can happen at multiple places, right? You might have your source operational systems that would now own a new data set or streams of data, whatever format is most suitable to represent that domain, to own that data. And I have to clarify that raw data that those systems of origin generate, we're not talking about their internal operational database. because internal operational databases and data sets are designed for a different purpose and intent, which is make my system work really well. They're not designed for other people to get a view of what's happening in the business in that domain and capturing those facts and realities. So it's a different data set. It's a different, whether it's a stream, very likely, or it's a time series or whatever format is the data that is native data sets that are owned by systems of origin and people who are operating those systems. And then you have data sets that maybe there are more aggregate views. For example, in a domain for, again, health insurance as an example, you might want to have predictive points of intervention, or critical points of contact that you want the care provider makes contact with a member to make sure that they're getting the health care that they need at the right point in time, so that they don't get sick and make a lot of claims on the insurance at the end of the day. So that domain itself that is responsible for making those contacts and making those smart decisions and predictability as when and where I need to contact a member, they might produce an aggregate view of the member, which is the historical records of all the visits that the member has done and all the claims. It's a joint aggregate view of the data. But that data might be useful not only for their domain, but other domains. So that becomes another domain driven data that the team is providing for rest of organization to support. So that's kind of the distributed domain aspect of it. The second principle behind that is for data to be really treated as asset, for it to be in a distributed fashion, be consumed by multiple people and still be joined together and filtered and be in a meaningfully aggregated and in a self-serve way used, I think we need to bring product thinking to the world of data. So that's why I call these things kind of domain driven or domain data products. Product thinking in a technology space, what does that mean? That means I need to put all the technology, kind of characteristics and tooling so that I can I can provide a delightful experience for people who want to access the data. So these people might be, you might have different types of consumers. They might be data scientists. Maybe they want to just analyze the data and run some queries to see what it's. They may not want to. They may want to use that data to convert it to some other, easy to understand way of data to kind of spreadsheet. So that you have this diverse set of consumers for your data sets. But for this data set to be considered a data product, and bring product thinking, you need to think about, okay, how I'm going to provide discoverability. So that's the first step. How can somebody find my data product? So it's a discoverability. How can they address it so they can programmatically use it? It's the addressability. I need to make sure that I put enough security around it so that whoever is authorized to use it can use it, and they can see things that they should see and not see things they shouldn't see. So the security around it. And well, for this to be self-serve as a product, I need to really have good documentation, maybe example data sets that they can just play with and see what's in the data. I need to provide the schema so they can see structurally what it looks like. So all of the tooling around kind of self-describing and supporting kind of the understanding what the data is. So there is a set of practices that you need to apply to data for data to become an asset itself. And finally, the third, I think, discipline that this discipline would help the data mesh is the platform thinking part of it. So at this point of conversation, usually people tell me, hold on a minute, you've asked me now to have independent teams, all of my operational teams, to own their data and also serve it in such a self-serve, easy to use way. That's a lot of repeatable, metal work that these teams have to do to actually get to the point that they can provide the data. Like all the pipelines that internally they need to build so that they can extract maybe data from the databases, or have a new, event sourcing in place so that leads it into, transmitting or emitting the events. There is a lot of work that needs to go, documentation, discoverability. How can they do this? This is a lot of cost, right? So that's where kind of the data infrastructure or platform thinking comes to play. I see a very specific role in a data mesh, in this mesh of, domain-oriented data sets, for infrastructure, for what I call self-serve data infrastructure. So all the tooling that we can to put in place on top of our raw data infrastructure. So the raw data infrastructure is, your storage and your backbone messaging or backbone event logs and so on. But on top of it, you need to have a set of tooling that these data product teams can essentially use easily so that they can build those data products quickly. So we put a lot of capabilities when we build the data mesh into that layer, which is the self-serve infrastructure layer for supporting discoverability, supporting documentation, supporting secure access, and so on, so that our teams and the success criteria for that infrastructure tooling, data infrastructure tooling, is the decreased lead time for a data product team or an operational team to get their data set onto this kind of mesh platform. Um, and and that's I think a big part of it. And I think it's at this point it's easy to imagine that, okay, if I have now domain oriented data products, clearly I need to have people who can bring product thinking to those domains. So you have people that play kind of the data product owners, and they might be the same person as the tech lead or same person as the product owner for your operational system. But what they care about is data as a product they provide into the rest of the organization. So the life cycle of that data, versioning, what features what sort of elements they want to put into it, what is the kind of service level objective in a way, what are the quality metrics that we support. If this data is almost near real time, it probably have missing or has some duplicate events in there, but maybe that's an accepted kind of service level agreement in terms of the data quality. And they think about those, all the stakeholders for that data. And similarly, now our software engineers who are building operational systems also have skill sets around using Spark or using Airflow or all of the tooling that they need to implement their data products. And similarly, the infrastructure folks that are often, dealing with your compute system and, your storage and your build pipelines and have providing those tools as, self-serve tooling. Now they're also thinking about big data storage. Now also they're thinking about, okay, data discovery. And that's an evolution that we've seen kind of when API, revolution happened. A whole lot of technology came into infrastructure like the API gateways and API documentation and so on, that becomes part of the service infrastructure in a way. And I see hopefully the same kind of change would happen with infrastructure folks supporting distributed data mesh.
Yeah, I think that, when I was reading through your post, one of the things that came to mind is a parallel with what's been going on with technical operations, where you have an infrastructure operations team that's responsible for ensuring that there is some baseline capacity for being able to provide access to compute and storage and networking. And then you have layered on top of that in some organizations the idea of the site reliability engineer that acts as a consultant to all the different product teams to make sure that they're aware of and thinking about all of the different operational aspects of the software that they're trying to deliver. And drawing a parallel with the data mesh, where you have this data platform team that's providing access to the underlying resources for being able to store and process and distribute the data, and then having a set of people who are either embedded within all of the different product teams or acting as a consultant to the different product teams to provide education and information about how they can leverage all these different services to make sure that the data that they're providing within their systems and that they're generating within their systems is usable downstream to other teams and other organizations, either for direct integration or for being able to provide secondary data products from that in a reusable and repeatable manner.
Yes, definitely there are parallels, and I think we can learn from those lessons. We have gone through the dev and ops separation, and with DevOps we brought them together, and as a side effect of that, we created a wonderful generation of engineers called SREs. So I think absolutely the same parallels can be applied, and those learnings can be applied to the world of data. One thing I would say though, going into this, distributed model with distributed ownership around data domains with the different infrastructure folks supporting that, bringing product thinking and platform thinking and all of that together to it. It's a hard journey, and it's counterculture to a large degree to what we have today in organizations. Today, data platform, data lake is a separate organization all the way to the side, really not embedded into the operational systems. What I like to hope to see is that data becomes the fabric of the organization. Today, we do not argue about having APIs, serving capabilities to the rest of the organization from services that are owned by different people. But for some reason, we argue that that's not a good model for sharing data, which I'm still puzzled by. So data right now is separated. People are still thinking, there's a separate team deal with my data. Data is like the operational systems, and folks are not really incentivized to own or even provide kind of trustworthy data. So I think we still have a long way to go for organizations to reshape themselves, and there is so much challenge. There is a lot of friction and challenge between operational systems and the data that needs to be unlocked and the consumption of that in a meaningful way. I am working with and also have seen pockets of this being implemented. But for people who get started, and where I'm starting also with a lot of our clients, is not day one. It doesn't look like a distributed ownership and a distributed team. So on day one, we in fact do start with maybe one physical team that brings people from those operational domains as SMEs into the team. It brings infrastructure folks into the team. But though it's one physical team, the underlying tech we use, like the repos for code that generate data for different data domains, are separate repos. They're separate pipelines. The infrastructure has a separate backlog for itself. So virtually internally have separate teams, but they're still working on day one. They're still working under one program of work. And hopefully, as we go through the maturity of building this in a distributed fashion, those internal virtual teams that are they've been working on their separate repo and they have a very explicit domain that they're looking after, then they can kind of, once we have enough of the infrastructure in place to support those domains to become autonomous, completely autonomous, then they can go out and be turn into long-standing teams that are responsible for that data for that domain. So that's a target state. I do want to just, I guess, mention that there is a maturity and there is a journey that we have to go through and probably make some mistakes along the way and learn and correct to get that to that point at scale. But I'm very hopeful because I have seen this happen, as you mentioned, parallel in the operational world. And I think we have a few missing pieces for it to happen in the data world, but I'm hopeful. Based on the conversations that I had with companies since this has started, I've heard a lot of horror stories and failure stories and the need for change. So the need is there. I've also been talking to many companies that have come forward and say, we are actually doing this. Let's talk. So they haven't maybe publicly published and talked about their approach, but they're in the kind of the leading front of changing the way and challenging the status quo around data management.
Yeah, one of the issues with data lakes is, at the face value, the benefit that they provide is that all of the data is co-located, so you reduce latencies when you're trying to join across multiple data sets, but then you potentially lose some of the domain knowledge of the source teams or source systems that were generating the information in the first place. And so now we're moving in the other direction of trying to bring a lot of the domain expertise to the data and providing that in a product form. But as part of that, we then create other issues in terms of discoverability of all the different data sets, consistency across different schemas for being able to join across them, where if you leave everybody up to their own devices, they might have different schema formats, and then you're back in the area of trying to generate master data management systems and spend a lot of energy and time trying to be able to coerce all of these systems to have a common view of the information that's core to your overall business domain. And so when I was reading through the post initially, I was starting to think that we're trading off one set of problems for another. But I think that by having the underlying strata of the data platform team and all of the actual data itself is being managed somewhat centrally from the platform perspective, but separately from the domain and expertise perspective, I think we're starting to reach a hybrid where we're optimizing for all the right things and not necessarily having too many trade offs in that space. So I'm curious what your perspective is in terms of those areas of things like data discovery, schema consistency, where the responsibilities lie between the different teams and organizationally for ensuring that you don't end up optimizing too far in one direction or the other.
Absolutely. I think you made a very good point and a very good observation. We definitely don't want to swing back into data silos and, inconsistency. The fundamental principle behind any distributed system to work is interoperability. So you mentioned a few things. One is the data locality for performance, like, data gravity, where the operation, like the computation will happen. Like, for example, your pipelines accessing that data are running close to your data and the data is co-located. I think those underlying physical implementations, we should bring those learnings from data lake design into the data mesh. They should be absolutely there. A distributed ownership model does not mean a distributed physical location of the data, because as you mentioned, the data infrastructure team is their job is providing that location agnostic or fit for purpose location as a service to, or storage as a service to those data product teams. So not every team willy-nilly deciding where I'm going to store my data or how am I going to store the data. There is a infrastructure that is set up to incorporate all of those performance concerns and the scalability concerns and the co-location concern of the data and computation, and provide in somewhat a agnostic way to those data product teams where the data should be located. So physically, if I'm on the same, on a bunch of S3 buckets or on an instance of Kafka or wherever it is, as a data product team, I shouldn't care about that. I should go to data in my data infrastructure to get that service from them. And they are best positioned to tell me where my data, based on my needs, obviously, and the scale of my data and the nature of it goes. So we still can bring all of those best practices around the location of the data and so on into the infrastructure. Discoverability is another aspect of it. So I think one of the most important properties of a data mesh is having some sort of a global and single point of access for, or single point of discovery system, so that as someone who wants to generate a new solution, I want to make a smart decision about get some insight about my patients in my health insurance example. I need to be able to go to one place, which is my data catalog, for a lack of better word, or data discovery system, that I can see all of the data products that are available for me to use. I can see who owns them, what are the meta information about that data, what's the quality of it, when was the last time it's got updated, what's the cadence of it being updated, get sample data to play with. So that discoverability kind of function, I see that as a centralized and a global function, that in a federated way, every data product can register itself with that discovery tool, and we have primitive implementation of that, which are just Confluence pages, to more kind of maybe like advanced implementation. So it's just that's a globally accessible and centralized, I think, solution. And one other thing that you mentioned was, well, now those teams, now that you leave the decision around how the data should be provided and what the schema of it should be, that hasn't changed from the lake, because the lake concern, lake implementation, that leaves that also to the, at least in its pure initial definition, to the data sources. But as I mentioned, interoperability and standardization is a key element. Otherwise, we end up with a bunch of domain data that there is no way I can join them together. For example, there are some concerns, some entities, like a member, right? the member in a health insurance in a claim system probably has its own internal IDs. In, I don't know, the healthcare provider system has its own internal IDs. So the member is a polysim entity that crosses different domains. So if we don't have standardization around adapting those internal member IDs to some sort of a global member ID where I can join the data across different domains, these disparate domains data, they just good by themselves. They don't allow me to do, merging and filtering and searching. So the governance, the global governance and standardization is absolutely key. And that governance and standardization sets standards around anything that allows interoperability, from how the maybe format of certain fields, how we represent date, time, and time zones, to how do we do polyseams of federated identity management, to what is the unique way of securely accessing data, so we don't have 5 different ways of security implementation or secure access model. So all of those concerns, I think part of that global governance and implementation of that, as you mentioned, goes into your data infrastructure as tooling that people can easily use as shared tooling. The API revolution wouldn't have happened if we didn't have HTTP as a baseline standardization, REST as a standardization. So these standards have allowed us to be able to decentralize our monolithic systems. We had the API gateways and API documentations as centralized place to find things, like find what are the APIs I need to use. So I think that same concerns and the best practices out of the lake should come into the data mesh and not get lost.
And from an organizational perspective, particularly for any groups that already have an existing data lake implementation, talking through this, I'm sure it sounds very appealing, but it can also sound fairly frightening because of the amount of work that's necessary. And as you mentioned, the necessary step is to take a slow and iterative approach to going from point A to point B. But there are also scales of organization where they might not have the capacity to even begin thinking about having separate domains for their data because everybody is just one group. And so I'm curious what your perspective is on how this plays out for smaller organizations, both in terms of the organizational patterns, but also in terms of the amount of overhead that is necessary for this approach, and whether there is a certain tipping point where it makes more sense to go from a data lake to a data mesh or vice versa.
Yeah, that's a very good question. On the smaller kind of scale organizations, if they have a data lake, if they have a centralized team that is ingesting data from many different systems, and this team is separate from the operational teams, but somehow because of the size they can manage, and they have closed the loop. And by close the loop, I mean it's not that they just consume data and put it in one place, but also have satisfied the requirements of use cases to use the data, and they have become a data-driven company. If you're there and you have managed to, build a closed, tight loop between your operational systems providing the data and intelligent services or ML-based services that are sitting on top of the data and consuming it, and you have a fast cycle of iteration to update the data and also to update your models, and that's working well for you, there's no need to change. A lot of startups and scale ups, they're still using the monolithic Rails applications that build the first day, and that is still okay. But if you have pain, and if the pain you're feeling is around ingestion of the data and keeping that data up to date, understanding the data, you see fragility, if that's a word. you see the fragile points of connectivity between the source being changed, and your pipelines falling apart, or you are struggling to respond to this kind of the innovation agenda of your organization. We talk about test and learn and build, test and learn, which requires a lot of experimentation, and your team is struggling to respond to change data to support those experimentation, then I think that's an inflection point to start thinking about how can I decouple this? How can I decouple the responsibility? And a starting point, a very, very simple starting point would be, let's decouple your infrastructure from the data on top of it. So your data engineers probably today are both looking after infrastructure pieces, which are cross-domain. They really don't matter what data domain they're serving or they're transforming their cross-domain. separate that into a separate team, put a success criteria for them, design success criteria that is aimed to enable people who want to provide data on top of that infrastructure. Separate that layer first. When you come to the data itself, find out the domains that are going through change more often, the domains that are changing continuously. Often those domains are not your customer facing applications, or they're often not the systems, operational systems at the point of origin. They may change, but the data they're emitting may not change, but maybe they do. Often they're the ones that are sitting in the middle and they're aggregates. However, find out which data domain is changing most rapidly. Separate that one first. So, put even a logical, maybe your data team is still the same team, but within that team, some people become the owners or the custodians of that particular domain, and bring those people together with the actual systems that emitting the data, if it's a system of origin, or teams that are aggregating the data in the middle, if it's an aggregate data, and start experimenting with having built that data set as a separate data product in a way, and see how that's working. I think that would be where I would start in a smaller organizations that already have many data warehouses, multiple iterations of it or recognitions of it, and they're somewhat disconnected, and they have probably a lake, and maybe it's not really working for them. Again, if you see the failure symptoms that I mentioned at the beginning of this conversation, you can't scale, you can't bootstrap, haven't become data driven. Again, start with finding those use cases. I always took a value-driven, use case-driven approach. Find a few use cases where you can really benefit from data that is directly coming from the source, data that is timely and rich, data is changing more often. But find use cases for that data, not just the data itself, but whether it's ML use cases or BI use cases. Find use cases, group them together, identify the real source of data, not intermediary data warehouses, and start building out this data mesh, one iteration, one use case at a time, a few data sources at a time. And that's exactly what I'm doing right now, because organizations that I work with, they mostly fall into that category, that kind of hairy data space that needs to incrementally change. And there's still, there is a place for a lake. There's still a place for a data warehouse. Like a lot of the BI use cases do require a multidimensional schema, well-defined, but they don't need to be the centerpiece of this architecture. They become a node on your mesh, mostly closer to the consumption use cases, because they satisfy a very specific set of use cases around business intelligence. So they become the consumers of your mesh, and not the central piece for providing the data.
And in your experience of working with different organizations and through different problem domains and business domains, I'm wondering if there are any other architectural patterns or anti-patterns or design principles that you think that data professionals should be taking a look at that aren't necessarily widespread within that community.
Yes, I think a lot of the practices that we take somewhat for granted today, if you're building a modern, digital platform, a modern web application, I think there is a space to bring those practices to data, and both data and ML. I think continuous delivery is an example of that. All the code and also the data itself, also the models that you create, are under the control of your continuous delivery system. They're versioned, they have integrity tests and tests around it. Making that deployed to production, which means release it so that it's accessible to the rest of the organization. So I would say the basic, good engineering hygiene around continuous delivery, those are not really well understood or well established concepts in both data and ML. So a lot of our ML engineers or data scientists, they don't even know what does continuous delivery for ML look like, because from making a model in R on your laptop, there is months of work and translation and somebody else writing a code for you and putting something on the in production that using its stale data that it was trained on, and there is no concept around my data changed, now I need to kick off another build cycle because I need to retrain my machine learning algorithms. So that continuous delivery, both in AI and continuous delivery, both in data world as well, like integrity test and testing for data is not a well understood practice. Versioning data is not a well understood practice. So think schema versioning or backward compatibility. I would say that would be some of the early kind of the technical concerns and capabilities that I would introduce in data engineering teams or ML engineering teams.
And are there any other aspects of your thinking around data mesh and the challenges of data lakes or anything else pertaining to the overall use of data within organizations that we didn't discuss yet that you'd like to cover before we close out the show?
I think we pretty much covered everything. I would probably maybe emphasize a couple of points. I think making data as a first class concern, an asset, and structured around your domains, it does not mean that you have to have a well modeled data. It could be your raw data, it could be the raw events that are being generated from the point of origins, but there is product thinking and self-serve and some form of it understood or measured quality and good documentation around it so that other people can use it and you treat it as a product. But it doesn't necessarily mean we're doing a lot of modeling of the data. The other thing that I would mention, I think, is I guess we have already talked about it, but I think the governance and standardization, I would love to see more standardization the same way that we saw with the web and, with APIs applied to data. So we don't have a lot of either open source, like a lot of different open source tools or a lot of different, kind of proprietary tools, but there isn't a standardization that allows me, for example, to run distributed SQL queries across a diverse set of data sets. I mean, the cloud providers are in a race to provide all sorts of, wonderful data management capabilities on their platform. And I hope that race would lead in some form of standardization that allows distributed systems to work, and intentionally. I think a lot of the technologies we see today, even around data discovery, is based on the assumption that data is operational data hidden in some database in a corner of the organization, is not intended for sharing, but we need to go find it and then extract the data out of it. I think that's a flawed predisposition. I think we need to think about tooling that would allow intentionally shared diverse set of data sets. And what does it mean? Like, there's a huge opportunity for tool makers out there. I think there is a big white space to build next generation tools that are not designed to fight the data, to fight this bad data hidden somewhere. They're designed to share and make intentionally shared and intentionally treated as assets, data discoverable and accessible and mergeable and queryable, but distributedly owned kind of data sets. So I think those are the few final points to overemphasize.
All right. And for anybody who wants to follow along with the work that you're doing or get in touch, I'll have you add your preferred contact information to the show notes. And we've talked a bit about it, but I'd also like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Standardization. I would just, if I could wish for one thing, was a little bit of a convergence and standardization in that allows still a polyglot world. You can still have a polyglot world, but I want to see something like convergence that happened around Kubernetes in the infrastructure and operational world, some similar, or the standardization that we had with HTTP and REST or gRPC and so on in the world of data, so that we can support a polyglot an ecosystem. So I think I'm looking for tools that are ecosystem players and kind of support a distributed and polyglot data world, not data that can be managed just because we put it in one database or one data store, just because it's used by one party, owned and ruled by one particular tool. So open standardization around data is what I'm looking for. And there are some, small movements. Like if you look at and they're not coming, unfortunately, they're not coming from the data world. Like, for example, the work of CNCF off the back of the serverless, thinking about if the events are one of the fundamental concepts, talking about cloud events as a standard way of describing events. But that's coming from left field again. That's coming from in operational world, trying to play in an ecosystem, not a data world. And I hope we can get more of that from the data world.
Well, thank you very much for taking the time today to join me and discuss the work that you've been doing and your thoughts on the matter of how we can make more scalable and maintainable data systems in our organizations and as an industry. It's definitely a lot to think about, and it mirrors a lot of my thinking in terms of the operational characteristics. So it's definitely great to get your thoughts on the matter. So thank you for that, and I hope you enjoy the rest of your day.
Thank you, Tobias. Thank you for having me. I've been a big fan of your work and what you're doing, getting the information about this silo of data management to everyone, and really making that information available to me, at least since I've become a data enthusiast. Thank you for having me.
I'm happy to help. Have a good day. Bye.